Welcome to another episode of VME End to End, a show where we have someone that's a little skeptical of VMs and someone that's a little more enthusiastic about them on the show to hash out all things VM. Brian, thanks so much for being here today. I've got a tricky one for you.
Okay, let's go.
Yeah. I want to know about cutting edge technology, like really pushing cloud compute machines to the limit. I think this is going to be one that's going to trip us up.
I have the perfect person for us to bring in and talk to about this. I would like to introduce Emma. Welcome, Emma.
Hi. Thank you for having me today.
Yeah, so happy to be able to talk with you. If I'm not mistaken, you made an amazing world record-breaking Pi calculator using Google Cloud and Compute, yes?
Yes, it was in 2019, so it's a little bit old, but it was a world record.
Yes. Can we get an overview of that project a little bit? What was it?
Sure. So there are competitions around Pi. The number begins with 3.14, and people try to calculate as many digits as possible. And the world record we did was 31.4 trillion digits on Google Cloud using 25 machines, spending 121 days and 100 terabytes of storage. And we did that.
But this scale is why I wanted to invite Emma in, because there's not a lot of people that have run machines full on for 4 months straight, and I think more interestingly kind of worked through where the bottlenecks are in a system when you try to do that. Like, where were the bottlenecks in this process? Sure.
So the bottleneck was the storage. So in order to calculate Pi, you need a lot of storage, 107 terabytes, but the amount that you read and write is enormous. We wrote about 8 petabytes, and read 9 petabytes. A petabyte is 1,000 terabytes, so it's approximately 17,000 terabytes of data you need to process. And the storage I/O was the biggest bottleneck.
This is mind-breaking to me because I would not expect cloud compute to be able to handle that. Like, that was my assumption coming into this. Was this one of the first projects of its type to do this, or is this like commonplace in the cloud?
I think it's getting more and more common these days. A lot of people just run high-performance computing, this type of massive workloads on cloud.
So then my question would be, what are some of the advantages of doing this in the cloud? Because if I did this on-prem, I kind of understand what that looks like a little bit. I'd buy a lot of my machines up front. I would try and work through it from there. How does it look like for the cloud?
So I think the coolest part of using cloud is you don't need to choose which machine or which architecture to use up front. So for example, if you're buying a physical machine, you actually need to decide how many cores you're getting, how much storage you're assigning to that machine, etc., etc. But with cloud, you can always try and test different parameters. For example, do I need 100 gigabytes memory or 200 gigabytes? Or do I need 64 cores, 128 cores? You can try and test these parameters in the real environment.
So you basically do small versions of it and kind of see how much work you get for a certain amount of time and money, and like see how that turns out.
Wow, this is really cool. Something I'm really curious about is, okay, you said this was in 2019 and it's not the new record now or whatever, but what would be different if you were coding the same thing? Say you were trying to do 32 trillion digits of Pi again. How what would change if you took that same code base now and just, I don't know, could you update it for some of the compute technology now or what?
Yeah, so with cloud, you can just change the parameters and use the latest CPUs and machines we have today. For example, we have the latest Intel and AMD processors. We have more memory per machine. For example, the biggest machine we have is 11 terabytes of memory. And we have newer persistent disk types that achieves lower cost and higher throughput. And we have increased the network bandwidth from 16 gigabits per second to 100 gigabits per second. So by using all of these, I think we can probably finish the calculation in a quarter of the time we did in 2019.
there's a kind of a saying, time is money. And at some level, that's just even more true in cloud, right? So if you make something faster, it costs less to run. So that's a big deal.
Can we actually talk about that a little bit? What was, like, say, the cost of this in 2019? And then you said it's, 4 times faster. What would the cost of it look like now? Just, estimates.
Sure. So if you don't work for Google, you probably pay a lot for this project. And it was about $300,000 to calculate pi if you pay the money as an external customer. And you get half the storage for half the price today, achieve the same bandwidth. So that cut the cost about 30% because the biggest cost was the storage. And we had a faster processor. We can use the Intel Ice Lake Xeon processors, and we have increased the network bandwidth. So in combined, it took about 4 months to finish the calculation. I think we can do something between a month to probably 40, 50 days. So you pay less per time, like you pay less per hour, and you finish the calculation faster. So by combining all of these factors, I think it's safe to say we pay much, much less today.
That's awesome. So like same project over time gets cheaper and cheaper. That seems like a win. But it seems like you also did a lot of, like there's a lot of variations for how things could be done. You talked about like, running experiments basically. If people wanted to run their own experiments on their own software, how would you recommend they approach that?
Sure. So there are tons of configuration and variables in cloud, and probably with your software you want to run in cloud. And of course you can automate some of the aspects for your software, and there is a tool to automate that for cloud as well. It's called infrastructure as a code, and we use tools like Terraform and Pulumi to actually write down all the configuration parameters as a script and run it. And the coolest part is you can automate the deployment and provisioning process. So for example, if you want to test with different CPU cores like 2, 4, 8, 16, 32, 64, then you just need to write a for loop and run the script again and again, and invoke the software and run a test for all of these combinations. And that's what you can do with the cloud.
Wow. Yeah, like I can totally see. Again, I'm still a little skeptical. I'm blown away that this is possible, but I see the benefit of being able to just say, let me try out all these different configurations for my workload. And so I'm curious, what are some other things that you think are pretty cool about this type of hardware that might not be obvious to someone like me who doesn't do this kind of stuff as deeply as you do?
Right. So you may think, hey, I can get the same hardware from a hardware store or hardware vendor, but it's actually not, well, it's complicated because you buy hardware, like you buy a new machine and you use it for 3-4 years, right? You don't buy a new server every month. With cloud, you just need to shut down the machine, change the configuration, and reboot, and then you get access to the latest hardware without paying any upfront cost. So if you want to say use the latest Xeon processor or SSD or NVMe or AMD Milan, then you just need to change the configuration, and then you keep all the data, all the configurations, and just get the latest hardware for like free, like without any upfront cost. So I think that's pretty cool. Like you can actually use the latest hardware anytime on cloud, and actually cloud is one of the earliest places to support such like latest generations of hardware.
Oh man, that killed my argument, because I was just going to be like, well, why don't I just buy the newest, technology? But a lot of times it doesn't roll out as fast like as it would to the cloud.
And you mentioned the networking got a lot faster?
Yeah, so network is faster. Obviously, you have the Ethernet and the switch and top of the rack switch and the whole backend. And I think the cool part of cloud is you don't need to think about the actual fabric. So we support 100 gigabits per second for network, and each machine can actually communicate to another machine with 100 gigabits per second, regardless of their physical position. So, like when you're actually designing a physical data center, you actually need to think of those top-rack bandwidth and how you distribute workloads so you get the full bandwidth for each machine. But with cloud, we design the network in a way that each machine can actually achieve the full bisectional bandwidth.
Oh, okay. So that's a whole thing, like from an architecture and planning standpoint, you just don't even have to worry about it, think about it.
This is so interesting to me. One thing I'm curious about is if you were going to do a project like this in the future, like if you were going to try and go for another record or something like that, would you still use cloud computers, or do you think you might switch over and use something on-prem, something more dedicated?
Because I work for cloud, I would use cloud, obviously. There are obviously pros and the cons. For example, if you want to use a specific hardware set or specific, for example, if you want to test a specific piece of hardware, then you might need to still get access to that specialty equipment. But for I think I would say 99% of the workload in the world, you can just launch a machine in cloud, and because you don't know which machine to buy before actually getting the machine. So for on-premise hardware, you kind of do the guesswork, and I think this hardware with this number of cores and this much memory is sufficiently big enough and not too big. But sometimes you don't have enough memory, or you don't have enough storage, or you may need to add some cores. You never know. And with cloud, you can just test everything, right? And you can always change the configuration. You can always add new hardware, and yeah. So you don't need to choose and invest at the beginning. You just change and adapt along the way.
This is a really interesting angle on the, people often say, if you're kind of doing a batch workload, then, maybe that's not the sweet spot. But there's this upfront, testing side of it where you're being more scientific and you're trying to figure out, what kind of computer, what kind of arrangements of the computers, and you can do all of those tests in really short durations, which makes them affordable to do a wide variety of them on cloud. Thank you. That's it. I'm in the middle of this, and that's an angle on this I hadn't been thinking of. So I appreciate that.
Yeah. Yo, Emma, thank you so much for coming in and sharing what you've been working on and the way you're able to push the cloud, cloud compute instances to the extreme. There's a lot that I didn't think was possible or didn't know was possible. And I hate to admit this, Brian, the more we talk, the more I start thinking cloud computing makes a lot of sense.
Imagine.
Well, yo, that's it for this episode. Emma, thank you. And if you're watching at home, definitely let us know of anything that was surprising to you. We definitely check out all the comments. And stay tuned for next episode because it's a special one. I don't know what's in store, but Brian said I can't miss it.
Oh, we do. It's going to be awesome. And yeah, so please hang in there, check it out. And, if you're living in the future already, just hit next on the playlist and join us. It'll be fun.